Hello, and welcome to this lesson on finding the probabilities of compound events. A compound event you'll see is when multiple things happen in one event, like flipping a coin and rolling a dice together. Okay, essential question says, how do I find the probability of a compound event? Fairly straightforward. Did you know that the probabilities of all possible outcomes will always add up to 1? That's because the probability of 1 means 100%. So like the probability of getting a heads or a tails when you flip a coin. Well, you think, yeah, that's guaranteed to be a heads or a tails. Well, there's a 1/2 chance of getting heads, which is 0.5 as a decimal. There's 1/2 chance of getting tails, which is also 0.5. If you add those together, you get, well, as a fraction, 1/2 plus 1/2 is 1. As a decimal, 0.5 plus 0.5 is 1. And if you change that decimal into a percentage, and you move your decimal over 2 places, it gives you 100%. So there's a 100% chance of flipping a coin and getting heads or tails, which you already knew. But maybe you didn't know that if you add up all the possible outcomes, you always get 1 as a possibility. Okay, a couple vocab words. I think there's a couple more on the next page. So a compound event. Well, if you know what the word compound means, a compound, like in science class, is when you have a couple different elements and you mix them together. Mix is the wrong word. And they're pushed together. Okay, that's a compound. A building can sometimes be called a compound if it's made up of a bunch of smaller buildings that are then attached together. You know, like if you do construction and there's like a wing here and they add a new wing there and they add another piece there, that could be considered a compound. So a compound event combines 2 or more events using the word and or. That kind of rings a bell, doesn't it? Back in inequalities, we had and inequalities and or inequalities. It's kind of like that. Mutually exclusive events. Well, exclusive. If you know what exclusive means, it means like it's the only one. Well, 2 events are mutually exclusive if they don't have anything in common. A good common example of that would be like if I told you to pick a even number and an odd number, not add, odd. Well, those 2 things are mutually exclusive. They don't share any numbers in common. Where if I said pick an even number and a multiple of 3, well, they share. That would be an example of an overlapping event now, because, for example, the number 6 is even. The number 6 is a multiple of 3. So these would be overlapping. They share something. Mutually exclusive events don't share anything. They have nothing in common at all. And those 2 words kind of tie into these 2 as well, independent and dependent, a little bit. An independent event is if the occurrence of one event has no effect on another. When I flip a coin, if I have a coin and a dice, when I flip this coin, does it change the probability of me getting anything from the dice? Does it change the probability of getting a 5 on the dice? No. The coin and the dice are completely separate. They are independent. Rolling this coin does not affect this. They're independent. Where dependent events, the occurrence of one event affects the occurrence of another. If I have a bag of names, here, those are people's names, and I wanted to pick 2 people to, I don't know, get $500. Well, if I pick out this person here, well, now the probability of picking another person here has changed. At the beginning, everybody had a 1/5 chance of getting picked. But once I pick him, the chance of picking my second person is different. So that whoever was left in here depends on who gets picked first. So now each of these guys have a 1 in 4 chance of getting picked as the second person to get the prize. So those events are dependent. It depends on who you pick first. Okay? So, probability of 2 things. So, for each example, imagine rolling a dice. Okay? What is the probability of rolling a dice? So, rolling a 2 or an odd number. You may see this notation. This is like the algebraic way of writing this statement. The probability of getting a 2 or an odd number. Now the good news is this is one action. There's one event happening. You're rolling the dice one time, which means there's only one probability we have to find. So right now, think on a dice. 1, 2, 3, 4. Ah, man. Hold this way. 1, 2, 3, 4, 5, 6. How many of those things are an odd number or the number 2? 2, 2, 2. There are 4 of them. 4 of those things were an odd number or the number 2, out of a total of 6. Just like we saw in the previous lesson, the formula is going to be the things we want over total. And then we can simplify that fraction down to 2/3, and that's the probability of getting a 2 or an odd number. Now, mathematically, what we're doing is we're taking the probability of getting a 2, which is 1 out of 6, the probability of getting an odd, which is 3 out of 6, and we're combining them together because it's one action. Just how many things could happen in that one event, that one rolling of the dice? A total of 4 possible things that we want could happen. Okay, so with OR probabilities, a lot of times you add. I can't say every time, but a lot of the times you do. Letter B. What is the probability of rolling an even number or a prime number? Even or prime. I recommend for a lot of these, especially if there's like a small number of possible outcomes, I recommend listing. This is an example where the adding of the probabilities together does not work. How many even numbers are there on a dice? There are 3 out of the 6. How many prime numbers are on that dice? 3 out of 6. In case you don't know, the prime numbers would be 2, 3, and 5. So if we would add those together, we would get a 6 out of 6, which no, that's not actually going to be the right answer. Now, if we list out our choices and do a little highlighting, okay, probability of an even number, that one's even, and that one, and that one. Probability of a prime, which ones are also prime numbers? That one, and that one. So this was an example of an overlapping event. These two things, even numbers and prime numbers, they shared the number 2. 2 is both even and prime. It's the only even prime number. And because these events were overlapping, you can't just add their probabilities together. This is why the listing and highlighting and coloring or whatever it is you're doing can be very helpful. So now I can see the probability is actually a 5 out of 6. In this one event, there's 5 things that I would have wanted to happen. A 2, 3, 4, 5, or 6. Those are all the even or prime numbers. This one is the only one that was left out. Letter C. Sabrina rolls a number cube. That's a dice. What is the probability she rolls an even number or an odd number? Why don't you go ahead and pause the video and do that one right now. All right. So 1, 2, 3, 4, 5, 6. If I can list out my probability, my choices, my chances very quickly, I will. So we want even or odd. Well, evens, boom, 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 boom. Odds, dun, 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 dun. So that's all of them. That's a 6 out of 6. That's a 100. That was supposed to be a fraction, but whatever. 100% chance of getting an even or an odd. Those events have nothing in common. Evens and odds are mutually exclusive. They're separate from each other. So we can add their probabilities together. Okay. I personally am a big fan of the listing. That will serve you well most of the time. Listing out your choices, highlighting, circling, and there'll be times where maybe that doesn't work out so well. Okay, a few more. You roll a number cube. Again, that's a dice. Find the probability that you roll a 2 or a 5. 1, 2, 3, 4, 5, 6. There's my 2. There's my 5. That is only 2 out of the 6 possible things that could have happened. So that's a 1/3, which I haven't done a decimal in a while. 0.33 repeated, which equals 33.3%. Okay, so I still can do those things. I just, for now, I've been sticking with fractions. One for you. You roll a number cube. Find the probability that you roll a number less than 4 or an odd number. Go ahead and pause the video and try that one right now. Okay, so probability of a number less than 4 or odd. That to me sounds like there's going to be some overlap in the numbers. And we can double check that. Okay, numbers less than 4. Boom, 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 boom. Oh, 4 should not be included because 4 is not less than 4. Numbers less than 4, that'd be these 3, or odd. So these would both be overlapped numbers. Both 1 and 3 are less than 4, and they are also odd. So those two would almost have been double counted if we weren't paying attention right. The listing helps. So now that gives me a probability of 4 out of 6, which is 2/3. Okay. Talking a little bit about the independent and dependent events. We talked before about independent events where if you would, well, out of this fish tank, if I would take this red fish out, which I can't actually do, I can't just grab one of these guys and pull them out, but if I would take this red fish out, there, I can do this. So I take the red fish out. If I put him back in, that doesn't change the probabilities of any of the other fish in the tank, right? Right now, I mean, the chance of getting a blue fish is 2 out of 1, 2, 3, 4, 5, 6, 7, 8. There's 9 fish in that tank. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Now, if I take this red fish and I go bloomp, and I put him back in, the chance of getting a blue fish is still 2/9. I didn't change any probabilities. That is with replacement. I replaced the fish after I took it out. I took it out, I recorded what I saw, I looked at it, and I said, oh, that's a red one. And then I put it back in. Okay. Now, if I would take that red fish out, if I would take this red fish out, and now we kind of imagine that he's not there anymore. If I took this red fish out, the probability of getting a blue fish is now not 2/9, because now there's not 9 fish in the tank anymore. Now it would be 2/8. That is dependent. Without replacement is a dependent event. because it depends on what you're pulling out the first time, changes the probability of all the other ones. Like the chance of me picking another red fish, instead of being 3/9 is now 2/8. Because if I pulled this red fish out, there's only 2 red fish left. Okay. So, with replacement is independent. Without replacement is dependent. It depends on what you've pulled out because you're not putting it back in. So let's see how this works. You have a bag of marbles, and that contains 2 red, 1 blue, and 4 green. Okay, so that's a total of 4, 5. That's a total of 7 marbles. Usually that's helpful to know. Find the given probabilities. All right. What is the probability of picking a green marble and a blue marble with replacement? Okay, so I want a probability of green and blue with replacement. I can't write today. Replacement. All right. So, what's the chance of picking a green marble? Since the green marble is the one we're going to get first, the chance of getting a green marble from the beginning of the problem was 4 out of 7. Right? There's 4 green ones, 7 total. Now, with replacement means I take out the green marble, I look at it, and I put it back in the bag. Which means the chance of getting a blue marble would still be 1 out of 7. There's still 7 marbles in that bag. I put it back. And anytime you're doing multiple actions, I picked out a green one, put it back. That's action number 1. I picked out a blue one, I put it back. That's action number 2. Anytime you're doing multiple actions, you multiply your probabilities together. Just like we saw in the previous lesson with the counting principle. Maybe it was the beginning of this one. I don't remember. When I gave the example of like, there's like 5 lunches and 3 juices and 2 fruits and 3 snacks. Well, each of those is a different action. You pick your lunch, your main meal. That's an action. You then pick your milk. That's a separate action. And because you have all of these different actions, you multiply those probabilities together. And that would give us here 4 out of 49 as a fraction. Just because I'm curious, as a decimal would be 0.082. I guess I'll round to the nearest thousandths still, which would be 8.2%. So the chance of getting a green marble and then a blue marble from that bag is around 8.2%. What is the probability of picking a green marble and a blue marble without replacement? Okay. So the difference being now, the green marble still at the beginning would be 4 out of 7. But the blue marble, instead of being 1 out of 7, now, imagine we picked a green marble out. He's gone. Well, now there's only 6 marbles in that bag as opposed to 7. So the probability of this blue one depended on the green one. And if we multiply them together, it's easier to actually do this in your head than on the calculator. 4 out of 42, which simplifies to 2 out of 21, which I could change into 0.095. That 0 makes a big difference. That changes it from being 95% into 9.5%. Okay, I think this is the same bag of marbles. Question for you though, what is the probability of picking a red and green marble with replacement? Go ahead and pause the video and try this one right now. All right, so I started writing while you were working, and and with replacement. So a red marble, the chance of getting a red marble from the beginning was 2 out of 7. All right. Now, with replacement means I took that marble out, I looked at it, and I put it back in. So there's still a total of 7 marbles in the bag. And there's 4 green of them. So when I multiply those outcomes together, I get 8 out of 49. And I'm just going to leave that one as a fraction. You can change to a decimal and a percent if you like, but that's what it would be as a fraction. All right. A box contains 3 blue pens and 5 black pens. If you choose one at random, do not replace it and then choose a second pen at random. Okay. What is the probability both pens are blue? Well, the first blue pen would be a 3 out of 8, right? There's 3 blue pens out of 8 pens total. Now, if I took that first blue pen out and I didn't put it back, the probability of getting another blue pen would be now 2 out of 7. If I took a blue pen out, there's only 2 blue pens left out of 7 total. 6 out of 56, and let's see, that would be 3 out of 28. I'm just going to leave fractions for now. I've done enough of the decimals and percents for now. What is the probability 1 pen is blue and 1 pen is black? Okay, so getting the blue pen from the beginning should be the same. I mean, we're back to the beginning of the problem. There's 3 blue pens, 5 black pens, so there's 3 out of 8 are blue. If I've taken one of those blue pens out, then 5 out of 7 of them are black. And we multiply together and we get 15 out of 56, and that does not simplify. So that would be done. And 1 for you. So the same 3 blue pens, 5 black pens, but now, what is the probability that you pull 3 pens that are blue from the box with replacement? I'm going to have you try this one. Go ahead and pause the video and try that one right now. All right, so with replacement means you pick it out, look at it, and you put it back. So that'd be 3 out of 8. The next time, since you put the pen back, there's still 3 out of 8. And the next time, there's still 3 out of 8. But because it's 3 different actions, you multiply it together, and that gives you 27 out of, is that 256? Or is it 512? 512. And that does not simplify either. Now, if you were curious what that would be as a decimal, that would be 0.053, which is 5.3%. Not very likely to get 3 blue pens in a row. A bag contains 4 red, 5 green, and 2 blue marbles. You randomly draw 2 marbles, one at a time. Find the probability that both are red if you replace the first marble. Okay, so I want the probability of both being red with replacement. Okay, so let's see. Probability of red and red with replacement. So that would be, well, there's 4 red ones out of 4, 5, 6, 7, 8, 9, 10, 11. 4 out of 11. Because there's 11 marbles in that bag, as far as we can tell, right? Now, with replacement means you put it back. So there's still 4 out of 11. The probabilities remained the same with replacement, giving 16 out of 121 as my probability. Could you do part B, please? Could you figure out what is the probability of picking out a red and then another red without replacement? Go ahead and pause the video and do that right now. Okay, so the probability of getting that first red is still going to be 4 out of 11. From the beginning of the problem, there's 4 red ones, 11 total. Now, if you've picked out a red one and you didn't put it back, now there's only 3 red ones left in there out of 10 total, giving you a probability of 12 out of 110. And that does simplify by 2, giving us 6 and 55, which I think is as simplified as we can get. In summary, how do you find the probability of compound events? Go ahead and pause the video and think about it right now. So you take, and a lot of times it's listing choices. If it's one action, list your choices. See what you can come up with. Up here when we were doing the dice, like here, we were listing our choices and highlighting the things that we wanted. That was one action. You roll the dice one time and you want these things to happen. That's a good way of doing it. When you have multiple actions, you multiply those probabilities together. Now, a type of problem we didn't talk about, and I'm okay talking about it now, would be like, what happens if I'm like the probability of getting a tails on a coin and a 3 on a dice? That's still 2 actions, isn't it? You spin the coin, you roll the dice. That's 2 separate actions. You'd multiply those probabilities together. That would be the probability of getting a tails on a coin and a 3 on a dice. Okay, so anytime you have more than one action, you multiply those probabilities together. And we saw what happens with and without replacement as well, and how that can change the probability of the objects left in the bag or the box or the fish tank, or whatever it is. Okay, thank you so much for watching this lesson. Until next time, toodles.